Today we will start with the first of our series on machine learning. This is number 001, the very first one in this series, created for those who have no exposure to machine learning and want to get started. So the way we will do this is we will learn a little bit of theory and then try out some code, then theory, then code, and so on and so forth. My approach is going to keep it extremely simple so that the concepts are clear to people who have no exposure to machine learning, and they get to a point where from that point onwards they're able to look at Google and other great YouTube videos and build on top of what they have already learned. So this is first of the series. I will try and keep the explanations as simple as possible. So what exactly is machine learning? If I have to overly simplify this, machine learning is method, technique, piece of code that we use to solve a class of problems that fall in largely the two categories, which is prediction. I am trying to predict something. For example, what is going to be the stock price of a particular company tomorrow? Second is classification, which means, is this a picture of a cat? You may want to ask, where is this used? So as I gave you an example, prediction could be, people who are involved in stock trading or share trading, those same things for me. But you understand what I'm going to say. So they would be interested to predict how the stock is going to move next day, the day after. Classification, one classic example could be, is this a car? I want to count the number of cars or number of vehicles passing through a point, and I want to plan the width of the road or plan the city. And I want to put cameras, I take pictures and I count. So there are other classes of problems, but if you understand that almost all of those problems would fall in one of these two categories by and large. So if we understand these two, we are good. So let's see what exactly is meant by prediction. Now, before I go, this is tutorial 1. I'm making a basic assumption that you have exposure to math and you know some bit of Python. For obvious reasons that machine learning is all about math. Python, because Python has a rich set of pre-built libraries that we can use to jumpstart our learning, development, deployment. So if you don't know these two, maybe you can learn Python, but if you don't know math, maybe machine learning is not for you. I mean, honest, I don't want to be disrespectful, but without math, there is no machine learning. So let's get back to this topic. All of us know this classic equation, y is equal to mx plus b. What this equation tells us is that for any value of x, I will be able to say what is y. If I have this, basically it means I can predict. So if x is time and y is some quantity, no matter what time it is, I can always say what is going to be the value based on this line. So if time is equal to tk, there is some value yk. So in machine learning, my entire objective is to find an equation which can, or my entire objective is to find an equation in which I can plug in my independent variables to know the dependent variable. And how I find the equation is the art and science of machine learning. So let's take an example. Let us say I want to predict the price of stock markets based on days. So this is my date and this is the price. And first day the price was $100, second day the price was 101, the third day the price was 99.7, and so on and so forth. And I have this information for last 100 days. Can I predict what is going to be my price on the 101st day? For this, wouldn't it be nice if I had an equation where the price P is equal to, let's say, 3 of date squared plus under root of 2. I just made up something. Now, every time I put the value of D, which is 1, 2, 3, 4, I get the value of this price exactly. Wonderful. Utopian view, but I guess you get the point. So if I could find an equation that can tell me what the price is for any given day, I have achieved my objective of predicting. In real world, it's not that simple. Whatever I predict, there will always be some error. So let's say for the first day, I might be able to predict it as 99.7 instead of 100 that's written here, which is okay. We all live with a certain degree of inaccuracy in machine learning world because it's all about predicting something. Now, therefore, the question is, how do I find out the equation? And this is what machine learning guys do. So the way it works is they take this entire data set and they divide it into two parts. So I have my input data, which is this data, right? And I divide it into two parts. I call one part as train data and the other part as test data. Generally, I have not seen any written rule, but generally, whatever is the input data, 80% of it is used for training and 20% of it is used for testing. You can ask, what is training? Training is nothing but the process of building or creating or devising the equation. In this case, it's an equation where the independent variable is the date. So I take this input data. So I had 100 points here, of which I take 80 data points, which is 80%, and use some techniques, which is what we will learn in future courses. And using those techniques, I find out my equation. And this is called model. After having found the equation, I will take this test data, which is the remaining 20% here, and then I will make prediction. So here is my date, here is my predicted value, and the actual value that is known to me. This is YA, the actual value. So for 81st day, 82nd day, and so on and so forth, 100 days. So I will take this day, input it, feed it here, and see what my model is predicting. So let's say it predicted 25. And then for 82nd day, it predicted 24. And so on and so forth. And the actual value was 26 or 25.5. So there is small error between what I predicted and what the actual value was. And remember, I wrote my equation as this. Generalized, if I say AD square plus root 2. This was the equation that was producing these predicted values. And using the test data, I computed this predicted values and I am now able to compare with actual values, and I see there is minor error. So I can go out and try out different values of A in my equation and continue to iterate over it until, and then again keep comparing my errors until I reach a point where I can either no longer improve the my equation in terms of accuracy, or I am satisfied with the error. And then I say I have finally built my model, and my model is FD is equal to, let's say this A value is 3.47 D square plus root 2. That is when I end and I say I have built my model and I am ready to feed in new dates. So now if I feed in 101 into this, which was my original objective, that I have 100 days worth of data, can I predict 101st day? If I feed in 101, it should give me a value, let's say 28. Hopefully, if I am a good machine learning person, actual stock price should be closer to this value. And then somebody pays me tons of money for helping them make money. That's fairly what it is. So we covered the prediction case. Classification works similar. Now, if we take this example that, again, remember, I build my model using the training data. So again, I'll take the example. I have a set of pictures that depict cats, and my objective is to come up with a model which is nothing but my equation. And again, I'm overly simplifying it, saying, this picture of cat can be, thought of as one single variable or can be made using a single variable. So I input these and come up with my equation, and that equation is my model. Again, let's say the model is something like ax square plus b root x plus k. This equation accurately describes the picture of cats. Now, from 100 cat pictures, again remember 80-20 rule, I used 80 pictures to derive this equation, and I am using the remaining 20 pictures to test and then check the error. And whenever I get the error, I modify A, B and K here until a point where my accuracy is very high, and then I say here is my equation, which is ax square plus bx plus k. Now every time we feed in a picture of some animal, it should be able to classify it as either it is a cat or it is not a cat. That's what classification could be. Therefore, if I go back, for people who have never done any machine learning is a set of tools, techniques, methods which I deploy or employ to solve primarily two classes of problems. One is when I have to predict something. Two is when I have to classify something. And in either prediction or classification, the approach is more than a rules engine. I've brought in a new term. Rules engine for programmers effectively is nothing but an if then else statement, right? Here the intelligence is coded into the source code, whereas in this case, if you see, the system is learning from the data that is getting fed to it. There is, purists will say there is supervised and all that. We'll forget all that for now. So we are not hard coding any logic here. Our piece of code actually is able to self-improve, self-correct. That's fairly what machine learning is. So now that brings us to the end of this past video. In the next set of videos, we will start with basic prediction algorithms and classification algorithms, and we will use a tool called Jupyter, Jupyter, Jupyter Notebook, and I am using Python 3.7. So set up your machine for these two, and we will start with basic coding on that. Thank you. Bye-bye. Have a nice day.